Welcome everybody, also welcome everybody on site who is visiting us online. So I'm Tamer Sinanoglu, I'm a director in the business development in the semiconductor area for Bosch. And actually I started also my career in 2005 in Bosch, and we also have it in the media, we call it "We Work Like a Bosch." I will give you today some insights about how me personally actually I see the world that Bosch Semiconductor successfully integrates the automotive world and the consumer world together. We also heard it from the speakers before that really the mobility is changing completely. So the cars are getting more like smartphones and everything else is changing in this case. And all those integration challenges that we have is something that I personally also have experienced in the past. And this is what I would like to share today. So starting first of all with Bosch and semiconductors. So honestly speaking, in 2005, when I was still studying and about to graduate, I didn't know that Bosch really had semiconductors at that time. So I was typically looking for, because I studied microelectronics, I was typically looking for typical semiconductor factories. And when I heard about Bosch, I heard about power tools for drilling machines, washing machines, and also cars, components for cars like brake systems or injectors and so on. But the recruiter told me that Bosch even has its own semiconductor in Reutlingen. And this really opened up my eyes. I was searching on the internet and I really saw that Bosch had a broad portfolio in the mobility sector. And then I thought, okay, really mobility sector, even at that time, was in the pace that a lot of electrification came in and a lot of topics was about to develop. And this is why I decided to go to Bosch. When I entered Bosch, I really saw that there were really fancy stuff done in the semiconductor area. Let me start with the typical one that maybe everyone knows is the MEMS sensors itself. So the MEMS micro electromechanical sensors are the one typically used also since many years for crash detection, for acceleration, for gyroscope, for stability sensing, and a lot of other stuff in the car. So looking to the automotive sectors, we as Bosch were typically used in the semiconductor area for very high quality, mature features, absolutely no failures, because you don't want that the airbag opens up if it's not intended in this case, only if it's really a crash. And this must be matured, and this is something that must be safe. I have to say that the volumes in automotive was not so high as you would typically expect. And typically every car has a few sensors. I mean, the sensor parts and ECUs has changed. There are much more now in the door, in the front bumper, back bumper, and so on. And also that have a lot of development, but the volume was not so high. Still, development for ASICs was very clear. You need to have for automotive design, automotive qualified technologies. You don't need to jump to the maybe latest single nanometer technology node. You must have an approved ISO certified technology, and you have to integrate safety and security systems, or let's say environments and applications that nothing crashes. A few years back, in the range of 2005 up to 2010, Bosch decided actually to use this technology to go to the consumer world. And actually we were really proud to say, guys, we have really the MEMS sensors under control, let's go to smartphone vendors, or at that time normal phone vendors, and say, would you like to integrate this typical acceleration sensor or gyroscope sensors into your phone? And at that time the device was a few centimeters big. And this meeting opens up our eyes. The phone vendors told us, guys, yes, I would like to integrate this application into my phone, but please, I don't want to integrate the phone into the sensor, I want to integrate the sensor into the phone. And this changed completely the requirement and opens really up our minds, because the requirements for the consumer topics was small, cheap, and fast. Not really what we were used in automotive. I mean, all these hundreds of ECUs and so on really was created due to this mindset that we had in the past, and this was growing, but at that time this opens up our eyes to say, not that way. We need to change a little bit our minds, and we change this with our people. So we really started to take our technology, squeeze it out, because the typical MEMS sensor has a micromechanical part, really moving, really mechanical in this case. There's an ASIC inside, you need dedicated packaging, and of course a dedicated testing to do it. We pushed the technology at that time. To be smaller, we come to the physical limits in this case. There are some limits that you cannot really overcome in this science. Very small structures are defined, even technologies even get thinner. there are still, even in consumer topics, crash tests like that the smartphone falls down from 1 meter to the floor and the sensor should not crash in this case. So also there were a lot of challenges that we had, and we pushed it. And we pushed it in different areas. We started even in the ASIC to change each building block, starting with a PET because you need to have low leakage. We started from an ASIC also with a power management because typical automotive has battery supply, you have unlimited let's say charge, and you can do whatever you want, but in a phone it's completely different. The design tools were still the same, and really go down and went even to IP vendors, like the memories that we were using was not the one that were typically, let's say, double memories and safety in different areas that you need for automotive to be safe and secure. No, we needed very simple memories, for example, and went with IP vendors to develop together a small memory size really fitting to the consumer development. And we managed it. At the end, our sensors that we have is really changing completely the world and your daily life because they are in every smartphone, also in cars and wearables, whatever you think of in the consumer topic. And why did we manage this? Because we really get the hint to say it must be small. Else nobody else would integrate it, nobody else would wear it in the consumer world. The design methodologies, the design tools were the same. But we changed the technologies and we changed our mindset. This is actually the MEMS part that I said. We are number one in the world and we hope to continue on this, and we have acceleration sensors, magnetometers and many other topics. But coming to the mobility part itself, there's much more actually. We as Bosch, and this is also was really the reason why I went to Bosch, because when I saw the portfolio it was very broad. We start from a small component, doing such sensors that we have, up to modules, up to ECUs like control units that we have, up to really big engines, machines, controls that we have. So the whole vertical integration would be possible in Bosch. But the important topic was again the people, because to understand what the end customer needs in an automotive world, actually, with all these complex ECUs and other topics, is something that you need to understand from system point of view. Really from system point of view, and have the understanding how to break it down to the small subcomponent where our semiconductor part at the end will contribute. It's similar with the partitioning where AI and other topics came. I mean, everybody's talking about AI. AI will come for sure, but you need to understand at which partitioning. There are still recommended, or let's say, parts that need to run with a, let's call it, classical way. But there are of course topics that are even unpredictable where you need AI. And this partitioning is something that you really need to understand to fulfill the need of the customers. What we do for the system integration or for the system understanding is also combining the semiconductor different areas and different portfolio types that we have. For example, power electronics. There are a lot of IGBTs and other stuff in the world going on, but it's changing. Electromobility is pushing also this technology, and also we are trying to follow it, and also we are trying to push this technology. So we have also in-house, of course, power MOS that we work since many years, but we also have silicon carbide inside, and we're also working on gallium nitride on GaN devices. Important is, of course, to understand what is the optimal way, the optimal frequency, the optimal working control to fulfill the needs. Not everything will be done directly with silicon carbide or with gallium nitride. There are still paths where, let's say, different components are needed. And this is the main challenge actually to understand. And coming from the consumer world, this is exactly where the world is getting complex and where you need to understand and also change your mind what the future is really needed. And we try to learn it, and we are still going to learn it to see what the future will show. A different part is our ASIC development, or let's say ASIC parts, where we do power management controls and so on. You mentioned also before, the previous speakers, that also there the whole infrastructure is getting too complex. It means the new EE architectures are not 100% defined yet, but it will change. They need new controls, they need new power modules, actually, and also they need different power management ICs to also fulfill all the microcontrollers, or the power for the microcontrollers and all other stuff. So it becomes more and more complex if it would continue the old way, but we have to change the mindset coming from the consumer world. That make it simple. They think about the end user application and they build it more like what the end user needs. And they don't build 100,000 different components inside and they have to talk with a dedicated interface to each other. No. The whole infrastructure is changing to keep it under control. And this was exactly also the speech that we had before. Really appreciated that. So Coming from the ASIC side and and sensor side, so comparing consumer and automotive for us was really like there are different levels. Consumer typically is fast, life cycles might be short. I mean, I designed really a chip that is still 10 years in consumer world and still continues, similar to automotive. It must be cost competitive. Also, automotive is going to be like this. Quality for automotive has a different level, I would say, than consumer. But don't miss the quality also in the consumer, and don't underestimate the quality levels in the consumer level. Because in automotive, I mentioned before, the volumes are not so high. You have it under control, you put more safety topics inside, the device can be a little bit bigger, so size is not always the big issue, except it's really the power modules where you also need to squeeze out the area so much. But when it really comes to consumer topic, size was important. But the volumes in consumer is so high. Also here you don't want to have a bad yield. This means really that the cost would explode in this case. There are factors more volumes produced for consumer than for automotive, especially for our MEMS sensor, for example. We produce 4 million every day in this case, and most of the part is really for consumers. You don't want to have a quality issue there. So maybe it's okay during the design phase to miss a feature. Don't to integrate a feature into your design to be fast and so on. But also here, the quality levels you want to reach must be still very high, especially with such a volumes. The sensors that we are producing, and also many other parts in our fabs, are really even in the combination with the automotive and the consumer parts. So manufacturing was already mentioned before, and also in the previous speeches there. Also there, we have even a second own fab for Bosch. It's the 300mm fab in Dresden. Also there we built a digital twin. It really starts the AI, the artificial intelligence topics, start even with the manufacture, with the construction. Also there we started directly in the early phase to build a digital twin to have more control in an optimal way how the media comes in, where to put which devices, which clean room should have which one, and how to optimize the lines. The second level that we did even in Dresden was really, and that was also one of the speeches that we had in the morning from Jens, is how we somehow ramp up the first devices in Dresden. I mean, there are really chemical, mechanical, electrical, and also thermal impacts inside. You don't control it with with an Excel table for a simple lookup. So there are tons of data that you want to create, but it's also clear to ramp up a manufacturing fast. You cannot wait 2-3 years to run hundreds of thousands of DOEs. So there we also use, of course, big data, but we also use artificial intelligence in this case. And the main challenge that we had at that time, we were not really prepared yet for this artificial intelligence items. Why? The data that we had tons of data also from the past. It was not prepared immediately to do a plugin for artificial intelligence analysis. So we spent more time to prepare the data instead of working with the data. But we managed it and we ramped it up. The third level that we had is in Dresden was even the qualification and the releases going to the OEMs. In automotive and in consumer world, let's say it really depends on the, let's say, Christmas market to say when you need to be ready to give the device in. They are a little bit flexible. They want to have the device as fast as possible to run it. In automotive, typically, conservatively was you run a winter test and you run a summer test. So if you miss this one, you miss 1 year. And then you maybe go to the next year. And we don't, let's say, spend the 1 or 2 years to release our new product where we have the full data under control in Dresden for the new products, or let's say to new ramp-ups in Dresden. And we use these AI topics. And we even convinced our OEMs to say, guys, we have the data under control and we can prove you, just even with the data we collected in the manufacturing, during our ramp-up, that the device will have exactly the same behavior as the ones you released 2-3 years before. And they believed us. And this is exactly the next challenge, how we learn from the different worlds, how we can really do one step further and not to run the conservative ways with all the qualification items before. We try to use as much data as we can to put the things together. The fourth level, I mean, this is what we have not done yet in automotive, but we are working on this, but is really an A product that we have from Bosch, or that we are designing within Bosch. Also here, the partitioning is so important. You need to understand where to put the artificial intelligence inside and where not. For the consumer part, we were even faster in this case, because we don't need to run all the qualification items, we don't need to prove all this, is it a dog artificial topics, is it a dog, is it a car, is it a bicycle inside. For the consumer world, we even now have a product with artificial intelligence inside. It's a simple movement tracker or sport tracker where just with a few movements it can detect, is it my movement or is it your movement? In this case, a simple IMU means an inertial measurement unit with gyroscope, acceleration sensor, and so on inside, really to say which individual person is running it. And how did we manage this? I mean, the consumer world that we are running with the sensors, the automotive world, the power electronic, and all other stuff. In our case, I can really say just with the people that we have. Because with all this vertical integration I mentioned already before, starting from the components up to defining the optimal system for the end OEM, this is the main unique selling point, and this is actually the real beneficial way how we go. And this is actually where we're still growing our portfolio, and this is also where we're still searching also for candidates. So if you're really experts and want to come to Bosch, feel free to contact me, to contact us. And I can promise you that we will bring a lot of fancy semiconductors from Bosch into the automotive world and into the consumer world.